here from Federal Institute of São Paulo. He's professor at the institute. His research interest includes open data, e-government, geographic information system, and inclusive knowledge-based system. Currently, he is a professor of informatics computing at Federal University of São Paulo and a postdoctoral research at the Department of
the city and the Chicago Loop Alliance to put sensors at every block along State Street and Randolph in the loop to better understand pedestrian and traffic flow. This is important for urban planning, it's important for businesses, but it also gives us data that will help us to improve traffic safety. The potential for the Array of Things project in the area of education is tremendous. We just finished an 8-week curriculum with Lane Tech High School, with faculty from Lane Tech and the School of the Arts of Chicago. And they designed a sensor experiment, collected data, and learned about sensing in general.
By publishing all of the Array of Things data, you're going to see academic partnerships with the city as we research problems like urban asthma. You're going to see civic technologists using the data to build new products and even businesses, and you're going to see community groups willing to use this data to understand
we are going to see this in the literature. Most of the authors mention those principles. And what are those principles? For example, open data is complete, is primary, timely, accessible, machine processable, no discriminatory, no proprietary, license free. It's a different vision to define open data. I will pick up some examples here. For example, to comply with complete, yes, which is the first principle, we need to make available, yeah, electronically all the data. Sometimes it happens, for example, to city house, local government. They have the information, but this information is written in paper. Yeah, maybe they have this information in scanned image, and they need to make this information available through the web, for example. That it's a very good way to comply with this the complete first principle. Then primary, what is primary? Yeah, we need to consider multiple views of data. For example, primary. Sometimes city halls and local government and industry itself, they produce a lot of data, and when they collect this data is in raw formats. All right, as it comes from a device or mobile application. Sometimes they like to make some extra visions of this data. They put a layer of visualization. Following this principle, the second principle, we need to keep always the raw format. Of course, you can, for example, develop a layer of visualization, but keep the raw formats. Put there. The ideal proposal is put the raw data and put the visualization layer. In the third principle, it's very easy to figure out timely. Of course, the data needs to be updated, otherwise it loses the value. The principle 4 we call accessible. The recommendation is to provide APIs. Yes, a good example of open data is to have a platform. I will show you some examples in a moment. When we have APIs, application program interface, that make this data available through many kinds of use. Not only, for example, that user that access a website and fills a form, for example, and get the data, but we need to make this data available through, for example, through machine readable data sets. When, for example, developer, yeah, designs a program, a software that can go to a data set and get this data. The principle number 5 complements the last one, yeah. But the main things we would like to emphasize here is to avoid, for example, PDF. PDF is a very friendly, it's a report-like format. But PDF is used to documents. The PDF is for documents, all right, not for data. That this is a misunderstanding we sometimes face. Local governments, for example, they like PDFs because it's a report-like. For example, you can pick up a PDF, scan, for example, make it available, and it seems to be very similar to a report document that we are familiar with. But it's not the data. To acquire, to get the data from a PDF file, for example, is a challenge. Yeah. And not many people know how to do that. The number 6 principle says no discriminatory. Yeah, it seems to be something that anyone can access. For example, we need to avoid here when we go through to a website and request the information, we need to fill out a form, give our name, give our document number, our date of birth, and a lot of information to get the data. No, it's not that way. We need to make available this, the data. Consider, for example, anonymous access. Number 7 of the principle says no proprietary, as I introduced to you in the last slide. In the next one, that has great importance, mainly when we think about government. For example, in Brazil, it's a great issue. The license, yeah, because when we work with a content, for example, when we get data, when we are going to make it available, we need to specify what licenses, what are the rights that users have over that data. So we need to give to user at least one kind of license that make it available freely without costs and so on. But how open data benefits cities? Well, firstly, we can say it promotes new ideas. Yeah, with open data, when we make available data from governments and from industry and from users in general, cities in general, we can make the data available, and people can go there and start developing mobile apps, for example. It's common to see, for example, hackathons. I don't know if you are aware about hackathons. Hackathons used to be very famous. Now we are facing a changing in this context, because hackathons is very good in a moment of time, when we make data available and we call a lot of students, a lot of teens, very with specialists, very experts on a specific topic, for example, and they come and they develop an app, for example, that solves a problem in the city. The problem is, how can we continue? How can we keep this application from hackathon to go on, yeah, to continue solving users' problem. It allows third-party apps instead of government apps. It's a very great issue, for example, to allow third-party applications to complement government applications. Opportunity for small business. It's a way to start new business. Yeah, we are in an academic environment. We know many students. For example, we can, for example, ask them to look at, for hackathons, or to look at available data, and ask them to develop an application, for example, and start with this application in order to start a new business. For example, it's a way to put the students in the market, to put the students with a business, and of course improves seat efficiency. Yeah, that sounds reasonable to us when we think open data and can we make it available. With the importance of open data, what we see nowadays, it's very common to see the comparisons. We have many organizations. Normally, those organizations are worldwide. Yeah, they consider, for example, the country as a whole, and they start comparing countries in the context of open data. So I'm going to show you two options, two of these companies that they try to benchmark the use of open data across countries. the benchmarking process, that's the way to compare countries. For example, the use of open data among countries. In fact, it improves accountability, yes, to make cities and government more transparent, to work with transparency. It emphasizes best practice because make data available, it's a best practice. We saw in the video of Chicago array of things, they started to think about smart city. For them to have a smart city, they start to think about open data. That's the important point. Understand, use open data for solving problems, yeah, because if you can compare one country to another, yeah, who is the winner or who is in the top ranking, you can improve the quality of those who didn't already. Mainly evaluates country-level initiative. That's a phenomenon that maybe we're going to have changes in the future. Most of the benchmarking, the comparison, this comparison process, they consider the country level. It's very difficult, for example, to find a local level of government, for example, benchmarking, to compare cities. Yeah, that's a phenomenon that we face, and we have a lot of work in the future ahead to compare cities, for example. I'll show you two of the main benchmarking we have available. Yeah, one of these is the Global Open Data Index. This was conducted by Open Knowledge Foundation, that organization that I mentioned to you. It's a little bit difficult to see, but Brazil is in number 8 here. Yeah, number 8, and we have these columns. Each column is, for example, an aspect of open data. We have transportation, we have transparency, we have local government, for example, information, and they put those variables here. They analyze the data set involved, and they give a grade. We are at position number 8. Maybe let's find here France, for example, number 4. Oh, you are better. France is better. Yeah. Okay. Yes. But look, it's a country comparison. Yeah. For example, this city, Natal, for example, doesn't count. Yeah. They see the country as a whole. All right. That's one weakness I find in this kind of comparison. Another comparison is from Open Data Barometer. Yeah, it is in 3rd edition, I think. They show in a map, for example, you have a scale here from red to dark green. Yeah, and you have the levels of openness, of data openness. We are greenish. Yeah. But this kind of comparison also considers only the country. Alright, so we have a good mark here, but in fact we are not good as it presents to us. I keep talking to you about open data and the benefits, and we need to think about open data everywhere, but actually what is open data, what it looks like, because sometimes I need to see something to understand what I'm talking about. I'll show you firstly the process to have, for example, a platform, a software platform to make data available as open data. We basically have 3 phases, 3 steps here. And the first one is the data acquisition. Yeah, the data acquisition. We are going to talk about sensor, mobile apps, collaboration, government, private sector, and how can we get this information. After getting this information, this data, yeah, I'm talking about data, the level of data in the raw format. We're going to remove a step, yeah, and we're going to think about the data presentation. How can we are going to show this data to users. So we enter in this boundary that we introduce the Open Data Catalog. Yeah, what's an Open Data Catalog? It's a software. All right, we have an infrastructure of software that make this data available and to present this data and to make this data available through APIs, for example. So in the data presentation step here, we're going to think about in a search and discovery. Yeah, when we have a data set with a lot of data, we need to search and discover. Otherwise, it's not valuable to have a data that nobody finds. We have metadata. We need to describe the data. Look, at this point, we have the raw data, but we need to put data over the data. We call this metadata to describe this data. For example, a temperature data set, for example, we need to say where did this data set come from, yeah, what periods, for example. Yeah, it's a way to make people search and discover this data. Another point is to have multiple data formats. That's another very important point, to have multiple formats. Yeah, it's not enough, for example, to have an Excel spreadsheet, a CSV, or a graph, or a document. We need to have many formats. We need to have a CSV. For example, we have to make available, for example, geographic information system as well, related to geographic position. So it's desirable to have the data available using multiple formats. So many people can be comfortable with with a specific format, for example, and go there and consume this data. The last step here is the data dissemination. In this step, we're going to worry about APIs, for example. This data catalog has a feature that expose the data through APIs, for example. Yeah, that's one point here. And advancing visualization. It's desirable to have advancing visualization. For example, we need to make some graphs, some charts to compare the data itself, the information inside the data. All right. What I would like to emphasize here is the data catalog. We have, it's a boundary, and the data catalog here is handling data presentation and data dissemination. I'm ready to show you the most famous data catalog we have, that's called SICAN. All right. SICAN. It's a very famous software. It's a free software. It's a free and open source. It's available at Open Knowledge Foundation website. You go there and download, and you can start deploying this data catalog. So many places, many countries are handling open data. They are implementing open data using SICAN, for example. We have many others data catalog, but the most famous is SICAN. SICAN stands for Comprehensive Knowledge Archive Network. It's a free and open source, as I said, and it's developed by Open Knowledge Foundation. Yeah, it's a very important organization worldwide, and it's available in many languages. I think 50. I listed a number here, but more than 50 languages, including French, including Portuguese, and including English. Also, we have, if you would like, for example, to test what SICAN offers, you can go to a sandbox. Sandbox is a test environment. You can go there and start putting, for example, your data sets. You can find and you can be familiar with this kind of software in order to deploy in your environment. It's a very good software that's available to everyone. Just to show you, I found a data catalog from Natal. Natal has a data catalog, but unfortunately it's a test instance. I found that later on. I put a screenshot here. It's a data catalog. It's thankfully it's a SICAN instance. Thanks God. They know what SICAN is because it's the most famous data catalog we have nowadays, and they implemented it here in the City Hall. But we see here, for example, 4 data sets. It's a test instance. But the problem is they put in under the official domain, so it's publicly available, but it's a test instance. But we do have a data catalog. That's a good information. I feel very proud to know that Natal has a data catalog implemented. Now they need to keep on putting data sets. That's the next step. We have a lot of SICAN instances around the world. Actually, the most updated number is more than 140 instances around the world. For example, we have data.gov. Yes, it's a North American data catalog. When they start putting open data available, it was in Obama administration when Obama started his government. He took many actions to make available open data, and they started using a proprietary platform, and they moved to SICAN in 2014, in the middle of 2014, I think. And we have Australia, we have United Kingdom, for example, Mexico. Talking about Brazil, for example, we have Data.Rio. They do a very good job. Recife, as I remember, was the first SICAN instance in production. They made a very good job in this point. And for example, Brazilian Senate. These are examples of SICAN instances that are deployed, that are in use nowadays, that you can check. They work in the same way. If you go to a SICAN instance, a data catalog with open data, we are going to see what you see at first. You see, for example, on a field that you can search for data sets. That's the most basic feature this kind of software offers. The most powerful is the API infrastructure. That is infrastructure that deals with API that has a lot of features to make available through APIs. We have other kind of data catalogs apart from SICAN. We have some proprietary softwares, for example, and I found this study. This study is a little bit old, not too old. It has 2 or 3 years, for example, but it's updated. We have here a comparison between the many kinds of data catalogs we have. For example, SICAN, as I was talking about. The big point here is denotes the full-fledged solution, and the smaller one denotes the limited solution, and when we have a cross, we don't have this feature. So it's possible to see, for example, that SICAN, that is an open source, that is a free software, everyone can download and use, has a lot of features that is possible to use. we have a variant that calls DCAN. Yes, it's a content. It's based on a CMS, content management system. For example, when we have the Drupal, Drupal over the CCAN catalog software. Socrata, it's a proprietary software. This kind of software is very famous as well, but we need to pay. Yeah, if a city hall, for example, wants to go there and implement an open data infrastructure, the city hall needs to pay. It's not cheap to pay for this. All right, but now we have a very good options here that offer a lot of features, paying with no cost at all. All right. The only weakness we face today in CCAN, for example, is the data visualization. Yeah, data visualization needs to be improved. Yeah, that's in the agenda of the developers to improve data visualization. It has some basic visualization tools, but it's a weakness nowadays. They are worried about this, and the developer maybe in the future, in the next version, we are going to see this solved. Another comparison from the same study, the same paper we have here, is we have also all the data catalogs. Yeah, there are others, all right, but the main data catalogs are here. For example, related to open solution. Look at this second column. It deals with if this data catalog is open or not. Yeah, in the majority of times here, when a data catalog is open, is also free. All right, we can get the source code for them. Well, I'll show you. It's very nice to know open data by some example. I would like to share you some very good examples that they are going on. Yes, they are real projects that you can find and know to go to the website, for example, and know these projects. We have this good project here. They call Blind Square. Yeah, Blind Square, the name of the solution. It's a software. Yeah, actually it's a mobile app. Yeah, that you can download. It's directed to blind people with blindness. Yeah, this kind of app uses data from Foursquare and the OpenStreetMap. I'm going to talk about a little bit more OpenStreetMap in a moment, and it can combine open data from these two good services to provide, for example, orientation by voice for blind people. Yeah. In this example about transportation, as I said, we see many solutions related to transportation. Yeah, they make a lot of apps, a lot of websites to solve transportation problems. This one is, it calls Turnaround, Fixing New York City Buses. As in New York, in many places around the world, the buses have GPS, built-in GPS, and they send information in a time basis. In São Paulo, for example, where I know, they make available the data set every minute. So we have a refresh of the data every minute. So we can access this data and, for example, develop an app or develop a report or make some comparison to analyze data from the transportation services. So we have the GPS, built-in GPS here in the buses, so it sends information, and a group of people, they had a very intelligent idea to make what they call the report card. Yeah, they made it was made by a group of people, not linked to governments. They are a group of users, for example, people who need to use people that need to use the transportation system, and they make this report card evaluating many features of the transportation service. For example, it's possible to measure the volume of the ridership, the amount of people that use the bus services. Another example is now related to city planning. We have an example from South America, from Buenos Aires. They call BA obras, like public works. Yeah, the building. For example, when a government make a building, for example, a facility to serve citizens. And they made a website for monitoring public works. It's based on official data, so this data comes from the government. And what's the good idea here? It has a very rich interface. Yeah, it's possible to make many kinds of comparison to see how the city is growing. For example, we are going to have a school there, public health unit here, and then with this kind of information, it is possible to plan, for example, where can we build, for example, a square, or where it's possible to build the houses, for example, for the public in general. It's a very good example from South America. I would like to show you the OpenStreetMap. I don't know if you know, if everyone knows this kind of service. It's like Google Map. Yeah, maybe Google Map you already know, but OpenStreetMap, that's the name. We call this the Wikipedia of maps. It's a collaborative map. In my opinion, this kind of service, this kind of system is the best news we have ever had until now. It's a very good map. You go there, you have similar services. You go there, you can see the base map of the city. But what's the main difference? The main difference is everyone can collaborate. You go there, for example, you have online tools. If you see a place that need an improvement, for example, you can go there and draw by your own the correction, the right way, for example, or to draw a sidewalk by your own. Just as an example, we have the Sochi. Sochi is a city in Russia, yes, where the 2014 Olympic Games began. Took place, in 2014, and it's not easy to show you the details, but on the left we have OpenStreetMap, on the right we have Google Maps. We know that Google is a multi-billion company. They have a lot of money to improve its services. And at Sochi in 2014, we took a screenshot that shows we have a lot of details that we didn't have in Google Maps. These details came from collaboration. So people start collaborating. So it's an example that the collaboration to show the power of collaboration. It works more than a multi-billion company, for example. It's another example that is related to resident city. For example, we have the Baltimore Open Air Project. That's another interesting project. They maybe if I remember well, it was built. They built a box, a very small box that can monitor many parameters from the air. They called they gave the name of this small box. They gave it the name is Weather Cube. But they start distributing this cube, this weather cube to people, and it's spread all over the city. So it's possible to monitor temperature, humidity, ozone, and nitrogen dioxide, for example. It's a kind of collaborative project that has this box, a hardware involved. Another example is Info Amazonia, Colombia. In this case, Colombia built this solution. It's a project to reduce deforestation. It uses data from satellites, but not only from satellites. They use data from journalists, for example. They rely on news, for example, that come from journalists, and they aggregate this information and show in a map in order to help the forest to avoid deforestation. Another about engagement is the Smart Dublin. It's another very interesting idea, to promote open data and smart city solutions. It's a project that aims at engaging people with smart technology, with providers. It's possible, for example, to see a government action that receives projects from industry, for example, and they make a partnership in order to offer the solutions to the citizen in general. Actually, it's not a solution, but it's an engagement process. The city, the Dublin, has like a workflow that a company, for example, that is interested in putting, for example, a meter or a device monitoring the city. They submit this proposal, and they have to pass to steps with some steps in order to put this solution available to the public in general. The city is trying to give solutions to the public as a whole. It's another solution from Copenhagen, Denmark. It's interesting because it combines public and private data. It's a challenge. We face the challenge in every day, because when we talk about public sector, it's very common nowadays to expect data from government. But the public sector, the private sector, it's very new. It's very new. We need to improve this, and they started a project. It's working right now, where they receive, for example, data from private sector and public. From City Hall, for example. So they have telecom, financial, transportation data coming from the private sector, and so they made a platform to integrate those parts involved. So I think it's the last one to show some example. We have, for example, School of Data. Who here is interested to know more about open data? How can start to learning about open data? We have the School of Data. It's a very famous website that you can go there and download many resources, and we can access courses to learn more about open data. There we have a lot of individuals and organization. We have Brazilian branch. A Brazilian branch, I think, in São Paulo. It's an organization and many individuals around Brazil that tries to disseminate, spreading the word about open data. Well, I would like to finish. It's almost finished now. Discussing some points I would like to show you to think about. Yeah. When we talk about open data. For example, keep the mantra open by default. That's a point that we try to repeat, keep repeating every time. Yeah. If we think about an action that make a city smarter, for example, say open by default. Okay. Think how can we open this data? Yeah. At the same time, we try to make a city smarter. Another thing is open data is not only for government. It's another challenge we are facing right now. As I said, governments, they are more familiar with how to publish data. They are more familiar with what is open data. But the private sector, they doesn't. They need to figure out what is open data, and we need to put more services using private data. Legislation is not enough. That's another phenomenon we face. In Brazil, for example, we have the access to information law. It's a very modern legislation about how to access and how to disclose information through the internet. But we see many problems around our country. Consider the absence of open data. I'm going to show you some examples in a moment. Disclosing data is not enough. We need social benefits. Yeah, it's not enough just to put the data available. We need to generate the social benefits. That's our aim in this matter. To have a clear understanding of licensing issue. Yes, that's a problem more. We see this problem more in Brazil. For example, they are not aware about licensing. Yeah, that's a very new topic for us. The spread of documents instead of data. As I said, PDF has a very bad reputation in the open data field. So it comes from our culture to just disclose, to just make available PDF. But PDF is for documents, not for data. And go beyond hackathons that I mentioned in a moment before. Hackathon is a first step, all right. But we need to keep this initiative for a continuous development of smart cities. All right. I would like to show you some highlights of a paper that I published in the beginning of this year, that I made a comparison. Actually, I assessed more than 500, almost 600 of city halls. Yeah, this paper is also available. I'll show you the situation. What we did, we entered and we had a good sample, as you said, almost 600 of cities. When we went in each website and analyze every single transparency page in order to get some parameters, in order to compare these cities. So I'll show you some information. For example, about the documents available, they are available using HTML. Yeah, that's the first option. The second option is PDF. The problem around HTML is a tagged document, so it's possible to structure the information inside HTML. But the problem is government generates HTML through a dynamic way. So what it is? You go to a government, a local government, for example, to access the data, you need to fill out a form with some parameters, for example, the date, the begin date, the end date, for example, what institution, and go to find to get the data. So it goes against a database and get the results. So it's a dynamic generated content. That's a problem because it is in the part of the deep web. Yeah, that's another buzzword. And it's related to some features that an open data needs to have. For example, machine readable. Yeah, it is red that means doesn't comply, and this bluish comply. All right. More than look how the amount of municipalities, cities, the amount that doesn't comply with machine readable, for example, principle to have open data. So that's I think that's the last slide, I promise. All right. Just to show you my current research, as I said to you, I found that a good amount of data is under the deep web. Yes, just to make a comparison, maybe you have heard about this. The deep web is a portion of the web where we cannot access. For example, Google doesn't reach the deep web because one reason for that is because the content is dynamically generated. As I said, when you go to a city hall and you fill out some parameters, a form, and you get the data dynamically, it goes against a database, and then you get the data. So it's not possible to Google to go there and index that page. So it's part of the deep web. What I'm working on right now is to try to find the data in the deep web. So in our first try, we have tested 27 Brazilian capitals. Yeah, we have crawled around 20 millions of links because there are many links. We need to go to the city URL from a city hall and spider the whole website. So at this moment we have crawled this amount of links, and then the next step is to try to discover what data is under this form. Yeah, we are working on right now this thing, and if everyone here wants to join us, can talk to me later on. All right. Some interesting source information. We have the open data chart who for those who are interested, and we have the Open Data Institute and the Open Data for the Development. Those three institutions and organizations, they make a very good job spreading data, open data issues. All right. Okay. Thank you.
Thank you, Andretti. We have time for questions.
Yes, it's one issue we are facing. The first thing here, we need to discover how many pages we have forms. For example, when we have password, we have a form, a HTML file, and we have a form with a password. So we need to identify one of these 20 million of links. Yeah, we analyze those 20 million of links, and we need to identify firstly how many pages have forms with PWD or password input type. So we keep this and try to apply some algorithms to break this kind of thing. All right.
More questions? Coisas.
Thank you for your presentation. Just to inform you, I don't know if Alison from Hacker Office is here, but IFRN has a CCAN repository with the swap. It's our internal system. Do you know it?
Yes, congratulations. Same congratulations to you because you know what is CCAN.
I know it because the Alison's master's degree thesis dissertation about the CCAN use here and other things related to it, to the project. So just to inform you, but I'm happy that you know it. Thank you.
Other questions?
Just a comment before you start. Try to sell this idea to the city hall, yeah, because they know what is CCAN as well. But I think they need to change the internal process to start putting data sets there, because they made a part of the work. Now they need to put the data sets. But congratulations to know and to implement a CCAN instance and help us to disseminate this idea.
I have two questions about the last slide also. First thing, I heard you saying you're trying to, if I correctly understood, track the passwords of government websites.
Yes.
Have you considered the legal issues that might come with that? That's the first question. Second, what kind of analysis or results are you expecting to find on this specific research?
Yes. Firstly, about the legal issue, it's very legal because we have nowadays the law. In Brazil, we have since 2011 a law that calls access to information law that is applied to every institution in our country. They obligate that they need to disclose the data. Yeah, they don't do that right now because they are breaking the law. That's the problem. The city maybe actually sometimes the city halls and the government don't know how to comply with the legislation. So the problem is over them, not from our side, because we're just trying to get the information that's available. All right. But sometimes we are not successfully because it's not easy to break, for example, passwords, or to go too deeper in a deep web, for example. And what information, responding to the second part of your question, what information we are going to find here? What we called, we created, to the best of our knowledge, we created this term, the deep governmental web. Yes, we are trying to find data from government that should be open, but they're not. All right. So if we are aware of this data, we can say, "Oh, we have interesting data, but this data is not open. Do something." Okay, read the law, read our law that you are obligated to make it available, but it's not. Yeah, that's the point. We are trying to access, to evaluate how far the city halls, because we have a lot of city halls. I don't know if you are aware of that, but we have 5.6 thousand of cities in Brazil. 5.6 local governments. So they need to comply with the legislation. We need to show this.
Another question there?
Hi, hello. You said that one of the challenges that we face about open data is that the private sector is not so involved. I'd like to know what could be done so that the private sector would be more engaged, because I think that they have no interest, because data means money, and they are not interested in opening the data. So I'd like to know what could be done to solve this problem, if you have an answer for that.
Oh, yes, yes.
If you pay, it's okay.
Yes, it's a very big challenge, especially in Brazil, because companies, they don't care about releasing their data. They don't care. What we can do is to show them the benefits. Yeah. What we can do, for example, in my opinion, Dublin has had a very good idea. Yeah, they put submitting process they promote the participation of the private sector. Giving them some benefits, for example, to use part of the government data. Yeah, the private companies go there, put, for example, a sensor, or they develop an app, for example, and they have part of the information. The other part of information comes from the government, for example. It's a way to show them, show the private companies that it is important to release open data, and they can have benefits as well.
Another question here.
Yes, I have a comment on that question. Dealing with data relates in general of maintaining your data collections. Today in the keynote speaker talked about veracity and quality, and keeping your data in such a state of grace implies experience, implies expertise, and implies a lot of infrastructure and resources. And I think that one aspect to be considered is that in general industry or government or whoever wants, I mean, if today somebody tells you export the images you have in your computer, you will see that it's not bad volunteering as a behavior of yourself. It is that you only have PDFs with horrible names and you don't even know what you have in your computer. So maintenance is something that costs a lot. I think that, and there's my question, what do you think about having a kind of business model behind open data that can move forward this process of sharing the data in good quality too?
Yes. Yeah, it's another issue, the quality of data, because everything I said, mainly I consider the availability of the data. Yeah, you get the data and make them available. How about the quality? Yes, how about the quality? That is a field, a very big field that studies this kind of thing. One, we do have some frameworks, some walk-arounds to try to solve this issue. For example, one of them is data provenance. It's an area. For example, data provenance. We have protocols. We have specific softwares that you can map since the data creation. What were all the transformation over that data in order to have some control over the quality. So an example is data provenance, as I remember right now. Data provenance maybe is a solution for that.
I have last questions. You mentioned about open data collaboration. You know, and if you could mention a good case of open data collaboration here in Brazil or in the world.
Yes, yeah, there are some interesting that I can remember right now. For example, in São Paulo we have Open Knowledge Foundation. We have a branch of Open Knowledge Foundation. Pretty much, as I said, Open Knowledge Foundation is a worldwide organization, and we have a branch in São Paulo. They have a lot of projects. I took part of 2 projects, especially with collaboration with many other universities and people, individuals. So open knowledge is a very good example. And our neighbor here in Natal, for example, we are in Natal, Recife made a very good job in terms of collaboration, because they start the first second instance in production in Brazil. They start the first one. So it's for consider the history of our efforts here in Brazil. I congratulate them for that, and they show a process of collaboration, because it's not easy, because they did it 3 or 4 years ago. So they faced problems with the software, because it was not very mature. So it was a collaboration process as well.
Good. Thanks a lot, Andrei, for the talk. Let's thank Andrei, please. Now we have time some coffee break, and it will be downstairs. Okay, and we come back 4 p.m. Thank you very much. Good afternoon again. Let's start our first tutorial with Javier Espinosa. Javier Espinosa is postdoctoral research in Barcelona Supercomputer Center and associated research at the French-Mexican Laboratoire of Informatic and Automated Control, LAFMIA. He holds his PhD in computer science from the University of Grenoble. His research concerns database and distributed system. Particularly, he is interested in the design of the next generation of stream visual data management system. He has participated in several national and international projects where he has been possible of the execution of work in package and the implementation of prototype, for example, Polybits, PEPs, CNRS, case European Union, and other ones. So Javier is a friend. We are happy to have you here. So enjoy your time now. Thank you very much.
You're recording. So, okay. So, Placido, thank you once again. It's really a pleasure to be here because I know Placido since several years now. We have worked together and many of my colleagues already have been here in Natal. So when I received the invitation, I said, this is my time. This is the time to visit IFRN and know the people in Natal. So this is not a joke, not also a compromise because I'm being recorded. It's really a pleasure to be here. So, before starting, how many of you already downloaded the requirements, the Docker plus the Docker images and everything? Please raise your hands. For those of you who are interested in doing the exercises, I have here the containers. These are, well, you have to download and install several things, but let's say that one of the most important things is 2 gigabytes in size. So if you want to avoid to use the network, you can take it from the memory stick. Also, well, before continuing, because I have a lot of material. So I have some slides. I want to introduce at least the basic concepts and then move to the tutorial. Before continuing, I just want to... How many of you are using Docker Toolbox? Docker, the native version? I mean, this is a binary question. Yes or no? And in principle, when I add the numbers, it should be the total of the participants in the room. No? Okay. So, let's see what happens. Let's continue. So, the idea is to talk about visualization of big urban data, right? So, before entering the real subject, I just want to present a fact. So, according to statistics, by 2050, we are going to be how many people in the world? 9 billions. That's a lot of people in the world. Right now, we are like, like 7 billions. And the estimation says that most of the population will live in the cities. This means that there is going to be a lot of challenges concerning traffic congestion. You already know some of them even in this city. Energy consumption, pollution, among others. So that's a fact, and that's the projections. One possible solution is the notion of urban computing. The promise in urban computing is that one can improve the cities, their environment, and people's life by processing urban data. By urban data, I mean, for instance, information about tourism, about energy being consumed in the city, traffic, among other kind of data produced in the city. These assumptions, this is based on the assumption that the city will be equipped with a lot of capture devices, sensing. So the previous speaker told you, show us a video with these internet connect devices for acquiring different kinds of measurements of about the city state. So, assuming that we have this city, interconnected city, we are expecting to have a lot of volume of data. I mean, you already know about that. The variety we have today, we have videos, images, documents, text, matrices, graphs, different data structures that you computer scientists or people working with data have to deal with. That's also a fact. Also, one important aspect is velocity. This information, even if it's not too high in volume, is produced sometimes at fast speed, sometimes more slowly. For instance, the temperature here in Natal, measuring the temperature every second doesn't make sense. It's more, for this specific scenario, it makes more sense to measure the temperature every hour or every 10 minutes, something like that, no? But you have to consider these characteristics, the velocity of the data production. Also, you have the veracity. The keynote speaker today told you about that, so I'm going to skip and present this. This is a video I took from the Barcelona Smart Cities Conference last year. Basically, this is a Huawei prototype where they are showing in real time information, data from China, one of the cities of China. So, as you can see, well, you have in one side, you have the video cameras recording everything in the, what is going on, and you have in this place the simulation. How true is this? I don't know. They were showing that in a big screen on the in the conference. So the challenge is to combine the data for presenting it somehow so people can make decisions. But I will talk more about that in a minute. So the challenge for doing this is basically to have a framework related to urban computing. The idea is that you will have a lot of sensors in the city. Even citizens are considered as sensors because they are producing data. This data is stored at some point in some location, and then you have a layer for the data management, indexing, computing trajectory. Well, computing trajectory is in the third level, which is the analytics of the data. And finally, once you have the data processed, analyzed, in principle, you pass to the next level, which is to publish the data or offer a service with that. Maybe this is the layer where you can find the open data principle, right? Like open smart cities like New York, which offers a lot of tons of data collections about the city. Boston also, Barcelona is one of them, and many others. Well, just a few words. These are some examples of problems that you can do when using this kind of framework. Improving, for instance, driving experience. If you use taxi, well, everybody knows Uber. I have seen that this is a popular service in Brazil. The basic principle of Uber is that they are recording everything and they are using this information for determining whether the next user will appear. So they have to really optimize the position of the vehicles, the number of vehicles at the specific moments during the day, and so on. Just an example. Also, gas consumption, electricity consumption. The examples of smart cities. I'm going to publish the slides. Here you have 5 projects that are using data, city-related data. The first one is from Grenoble. They are collecting data from one of the highways in in the cities in order to detect the number of vehicles during the day. There is also some nice videos right there for analyzing the CO2 emission in Singapore in different parts of the city. This is also a nice video. These are projects from MIT, but people from the urban department. So this is an analysis in Singapore about the offer of taxis in the city when during rainy days. So you can see how when there is no rain, almost all the taxis are there, but when the rain starts, suddenly taxis disappear. They are all occupied, and so on. This is a really nice project. The one in the middle, basically the idea is that having traffic lights, it's a waste of, it's not optimized for the city. Why? Because maybe it's midnight, you are waiting the red light and there is no vehicle, so you can cross, right? So in this project, what they are saying is that if you monitor all the vehicles in the crossroad, you can automatically inform the vehicle about the speed and when to cross. So you remove the traffic lights and you put some kind of intelligence, and the intelligence says, the theory says that traffic will have to go fast just because of that, just because of removing the traffic lights. So, okay, so these are some examples about applications using urban data. So, what I want to talk to you about is about obtaining value from data. In this case, big data. We already heard about volume, velocity, variety, and veracity. The next one is value. Which is the real value of the data? In general, you have, well, you don't see here, but this is the data processing in one slide. This is like pumping oil. So you have in this part the data who is being generating for any industry or sensors or whatever, and basically you are doing a lot of processing so that final users can take decisions about that. Talking about taking decisions, the European Union has a specific group association called the European Big Data Value Association, and their only job is to define the tools, the challenges, and the requirements so that Europe can move and profit from the value of the big data. Here you can see the chain. You start by acquiring the data, then you move to the analysis process. For the data acquisition, you have all the type of sensors, streams, event sensor networks, structured data. For the analysis part, you can do the analysis in memory, in real time, pattern recognition. I mean, every possible scenario is there. Then you are supposed to store the data and curate. And finally, and this is the important part, is the visualization. Why? Because at the end of this chain, there are humans. There are still humans. And they are the ones that are supposed to take the decisions. And we are very visually oriented. So the idea is to use human reasoning about visual patterns, and in that respect, I'm going to start to talk about data visualization. The idea behind data visualization is very simple. This is the book definition. Is basically you want to communicate an idea, well, information to a public using visual objects, circle, points, lines, bars. And you use all these visual objects to compose a graphic. The goal, why do you want to use visualizations? Because they allow you to find patterns on the data. I'm going to show you an example. But also, I don't know if, probably in Brazil you have some journals, digital journals, which use a lot of web technologies for telling you a story. Like, for instance, the New York Times, El País in Spain, and the Guardian. If they really want to show the people about the reasoning of using some kind of data, they start saying, we have finding that there is a lot of pollution in the city. Let's analyze this in different periods of time and blah, blah, blah. So this analysis is called storytelling. So using visual representations allows people to tell stories to convince people. Usually the government should use these techniques for convince you about how good the decisions they are taking are good. I mean, so let's see an example. The people that loves mathematics will find this interesting. Basically, we have 4 data sets at the left. These 4 data sets, well, these are X and Y values. These 4 data sets have the same statistical properties, same mean, variance, correlation, and so on. Just like that, probably you will say that these data sets are equal or represent the same information. However, if you build a graphic from there, you see that they do not they don't fit in the same space. I mean, they represent different things. Don't believe it? Well, next example. Here you have the same statistical properties, but when you plot it, something different appears, right? So don't trust the statistics. They are good at the beginning, but you have to plot. The one that invented this, it was a statistician. So this is another example, one that is supposed to be one of the most beautiful visualizations ever. It was made by a French engineer to show the number of soldiers that marched from Paris to Moscow and how many of them came back. There are 4 variables that you can see here. You can see the number of soldiers. You can also, well, it is difficult to read, but along the story you can see the name of the cities where the army was at that specific period of time. You can also see it at this point. You can see the scale of temperature. So, and well, the fact that the black line is when they retreat. So basically, what you can analyze and decide that probably it was the temperature that make that French lost the battle, plus other things. So you have 4 different variables presented in the same graphic that gives you insight, more information. This is another useful example about how visualizations are useful. For instance, this is a true story. In the 1854, there was a outbreak of cholera, and people didn't know how cholera were propagated. So, at some point, someone called Jon Snow, which is not the character of Game of Thrones. He decided that he started to count the number of people saying that the cases, I mean, and he discovered that the source was the water pump. Surprise! So cholera propagates by water, and because of this, he is, let's say that this is the founding event of the science of epidemiology. So, and this was the result of making a map. So the idea is that if you have the information and you visualize it, you can find interesting stuff. So there are different types of visualizations. Scientific visualization is when there is a match between what the data you have and a physical object in the world. Information visualization is when you have abstract information, for instance, having data from Uber. They represent points in the space, but this is more related to information that other stuffs. The last one, that's a joke. Information graphics is the mix between information visualization plus some kind of dynamism. But this is if you have to take something away from here is the fact I said we humans are at the end of the data decision process. What happens, the fact that help us to take decision is that at the brain we have some properties that are called pre-attentive processing that allow us to take decisions without reasoning. Just the fact of seeing something will pop up a decision. Let me show an example. How many trees, number trees, are here? What about if we change just a little bit the intensity of the color, some gray? So you don't have to think, it just pop up. Another example, which is the max and minimum value. So you are thinking, I start from the top, I compare with the second one, I take in memory. But what if you use bars aligned to the same point decision? So you see, there are some attributes, visual attributes, that help us to take decision faster. So there are a lot of different values. I'm going to skip that. There are also some interesting properties about the visualization. For instance, the Gestalt perception. Basically, you already know. Look at the one at the right and down. And this is the classical. What do you see? Two faces, or I don't know the name. A candle. No, the one there. A candle. Candle base. No, candle foot. Well, so basically, it's like, for instance, these are separate circles, but your brain tells you that they are connected, but they are not. So normally, a visual designer has to take into consideration these kinds of principles. Otherwise, when they propose a logo, the idea is not going to be, the result is not going to be good. That one, the designer says that this is a pagoda in front of the rising sun. And there are many others like that, the failures. And just because of the perception, there are different things that you have to take into consideration. So, I'm going to skip this. So, there are, well, this is interesting. There are visual properties can be ranked among those who are accurate and those who are not. So when you have point, lines, bars, size, direction, this is good. When you start to use colors, shapes, this is not really good. So using pies, graphic pies, not recommended. 3D graphics, not at all. Try to avoid them. They are nice, but they are not useful. So, and this is the point I wanted to present you. This is the normal workflow when you want to extract visually extract information from a data set. You have the raw data set, then you transform the data in some kind of tables, because tables are good for plotting, and then you decide which metaphor or points, line, bars, or whatever kind of graphic you want to use, and you view the result, you explore. The result is not interesting, you start over. Well, the first part, the raw data, you usually have to put the data, you have to filter it because of the size today, because we are working, talking about big data, and you have to do a lot of processing before passing to the part of making the visualizations. So, today, for starting the plotting, you have to do things before. Let me skip this. Well, for those who are interested in the visualization things, there are different. This is a visualization taxonomy that you cannot see. However, this one you can see. This one. So there are catalogs of visualization, and if you want to compare or see some spatial data, which are the best graphics for visualizations for this type of data, you go to the catalog and you have all the possible options. You have to try different graphics. That's the idea. Also, here you will see at home these are the guidelines from the Financial Times about the main decision process. If we want to compare economical variables, we use, and here you have all the possible plots. Plotting one variable, no, I'm going to skip that. This is very for when doing statistics about the number of time. This is funny when you have different variables. You can plot them all at the same time, but you have some restrictions. These are the parallel coordinates. Several attributes plotted at the same time. You can see the relationship among them. These are the vehicles produced in the 70s. So basically, less cylinders in principle, less cylinders, more economy. But if you want to compare two different dimensions, like the economy with power, in this kind of representation, it's not the best one because, well, you have to sweep the order of the bars to compare them. So, just to let you know that there are different ways of representing things. For instance, this is, I love this one because you can see how many people survived the Titanic. This graphic is called a parallel set. So, every line represents 100%. You can see the percentage of those who perished, those who survived. Among those who survived, how many were female, how many were male. Among female, how many were adults and child. And can you conclude something just from seeing this visualization? Something. Second class, first class, third class, group. Who survived the most? I'm going to say it in Spanish. Mujeres y niños primero. Well, you have evidence that the rule applies. So other type of graphics, star plot. I'm going to skip this. They are really nice, but I prefer to jump into other interesting matters. So, well, this is important. So there are different types of data. You have data that is hierarchical by nature. When you have this kind of data, you use maybe trees, maps, star bus. You have matrices, you have geographical data, temporal data. Tomorrow I will present how to visualize information, geographical information, and temporal information. But today I'm just only showing you how to, for instance, how to represent networks. You can either represent them using a matrix or a node link diagram, the classical one. And of course, if you add animation, you can explore the data set. Now, with respect to big data and the fact of visualization, today, well, you have heard probably about the data scientist. The data scientist is someone to know how to code in principle, to know or know how to use some statistical tools or models for exploiting the data. But this is a very confused term because today what happens is that people dealing with data scientists have to know a lot of infrastructure, frameworks, languages, and so on. At some point, if they want to present the results, they also have to know either web programming or using more tools for presenting the information. So this is like just a picture about the ecosystem, right, of data scientists. So when you want to build a visualization, you have two options. Either you use a programming library, which means that you have to code, or you use a software package. The most popular is Tableau for people that is not concerned with the data processing, but more with the analysis. This is the same thing. So some examples of programming libraries. Those who, for instance, D3. Who knows D3? The youngest one. The youngest one. Plotly is web service for also plotting. R can be considered a programming library. Packages, Tableau for plotting multidimensional data. Node, Excel for when you have graphs, and so on. But sometimes having these kind of tools is not enough. You need a specific infrastructure for dealing with the quantities, just considering volume. Remember, volume, variety, velocity. Just with volume, you need a specific infrastructure. So here you have the infrastructure of Sandia's lab, which is one of the most important laboratories of research in the United States. Basically, in this infrastructure architecture tells you that they have defined several layers of services for managing each step of the data. The acquisition, the data sources, different data services for data reduction, data analysis, and so on, just for reducing the data and presenting some graphs. This is another example using a technology called Spark. Who knows Spark? That's good because we are going to work with Spark. So Spark basically lets you code in clusters, run applications in the cluster for processing the data. And here you have the cluster is in the right side of the slide, and you have a web server which allows clients to connect and have a graphical user interface for interacting with the cluster. So for ending, let me show you some examples of this Twitter. I don't see a thing here. Presentation. So for instance, this is how things happens in Twitter. So basically, you know, Twitter, they have tons of data, and they have a specific team who deals with the visualization, which produce some really nice visualizations. So what they do in this slide, they present a tool. They use Pig plus other formal tools for defining scripts that are run in the cluster, and they move from a big data set to a small data set. And after this point, they use their knowledge. They are geeks, so they use web programming tools for producing the visualizations. Some examples of the visualizations. So tweets, remember, tweets have text, time, and some of them have geographical information. So just time, the evolution about this was what? The campaign of Obama. No, what happens? The evolution of the a trending topic when Bin Laden, when ABC, well, with the news told that Bin Laden was dead. So you can see the evolution of the subject. Just geographical information. We are going to work with this kind of example. This is adapted for the urban data. So where are the most tweets in the city produced? You can see them. Text. Brazil scores the first goal. This was during 2008. No, I think this was the World Cup. But according to the number of words, the frequency is the size of the word. And some other time plus geographical information. Well, and I'm going to skip this. This is just to show you how they use frame clusters. They run scripts, and then once they have the data, they move to produce this kind of visualizations. And I think I have the, yes, if you go to this link, is interactive.twitter.com, you will see a lot of their work. So just, do you have any question before moving to the hands-on? Nothing? So, as I said, we are going to work with the Spark. Now, the challenge, what we are going to do is like three different things. We are going to visit the full big data chain value, well, we already have the data. I put it on Git. We are going to clean it. Then we are going to conduct a very simple analysis, and then we are going to plot it. Oops. So for the data processing part, we are going to use Spark, which is a solution from Berkeley AMP Labs for processing data on clusters. But the principle, what they try to do is to do everything on memory, because they are tackling a specific kind of problems, which are iterative algorithms. So just to give you an overview, which you cannot see, but basically the Berkeley is proposing different tools which can be combined together, and this is the new layers of the database management systems for today's challenges. So Spark is here is the execution engine, and on top of the execution engine you have different solutions for dealing with streams, for instance, for the velocity of the data. For the variety, for instance, if you have graphs, you also have on top of Spark some libraries that can process graph data. What else? If you want to run machine learning algorithms, there is also a library for that on top of Spark. They are using this in projects like genomics, cancer genomics, smart buildings. So the principle in Spark is that you will have the motivation behind the Spark is the fact that the solutions at that specific point in time, basically what they did is that they put all the data collections were in some place, and then using a programming paradigm called MapReduce. Who knows MapReduce? Most of you should know MapReduce. I mean, the basic idea is that using just two functions, map and reduce, you can develop a lot of applications. Almost all possible SQL expression can be translated to a MapReduce program with two functions. One advantage of doing this, I'm going to. So the basic principle is that you have your full data collection here, and each of these map functions are going to be executed in a node inside a cluster. So the advantage of this strategy is that the collection can be split and move it into each of the nodes in the cluster. And then the map function will produce a result that will be aggregated in the reduce column. So if there is any problem or failure with a machine, it is not a problem because the environment knows about that, and if the machine stops working, the environment will replace the machine with a new one. So the principle of MapReduce can be here. For instance, this is the classical example for counting words. So you have, well, this is not a example, but let's imagine that you have thousands of lines of all Shakespeare books. So you have all the lines of the collections, and you want to count the number of words in the frequency of the words in the collection. So you have a map function, basically the function will receive as input each line, and will produce for each word a tuple. The first element of the tuple is the word I have seen Bueno. So this is the first word and the fact that I have seen it. And then the environment, what it does is it is going to aggregate all these tuples based by a key. In this case, the key is the name, the word. And after that, there is the reduce function that will receive all those elements having the same keys. and is the responsibility of the reduce function, for instance, to compute the number of the frequency of the words. So this is just an example, and as I said, with that you can do a lot of the stuffs. So in the Twitter example, I told you that they use a programming language called Pig Latin. So Pig Latin is a higher level programming language. So this is 1, 2, 3, 4, 5, 6, 7, like 8 lines examples using Pig for computing the top 5 pages accessed by users between 18 and 25 years. And you cannot see, but this slide is full of text, of code, and this is the equivalent to MapReduce, to the MapReduce version. So you have different tools for that. So I'm going to skip this. Let's focus with this. So this is one example. This is a Spark application. It's like a script. At the right, you have an example of a cluster. So in this example, what we have is a cluster with 1, 2, 3 nodes called workers. There is one master which controls the workers called here, well, the driver don't pay attention to that, but the fact is that this program will be executed on the cluster, and every time you have an instruction, we will see the details with the code, but basically every line will result in something what they call RDD, resilient distributed data sets. I suppose I have an example here. So this is, I prefer this one. So this is the cluster. You have different machines acting as workers. All the work will be conducted in the workers. Then you have a manager. This is the master. Then you are going to be seated here, and you will interact with the cluster via a Spark context. This is your entry point to the cluster. One important thing to know is that when you connect to a cluster, usually you ask a number of resources. You say, hey cluster, give me please 5 cores and 1 giga of memory RAM, and the cluster will and the manager will try to check whether it can give you this, because there are other users in the cluster. So most of the time you have to be aware about the number of resources that you need. For instance, in Barcelona Supercomputing Center, you are always on the queue. You never have the full computer besides, so you have to wait until the machine is ready, and they give you just slices of the machine. So you connect to the cluster. So the idea of the resilient distributed data set is that you are going to load into the cluster your data set that is going to be distributed among the nodes in the cluster. Now there are 2 ways of having RDDs. Either you have a classical data collection like a list in Python or an array in Scala, and you send this collection inside the cluster. So you are here and you create your list and you send it into the cluster, and the cluster, well, Spark will create a distributed data set across all the workers, all the nodes in the cluster. The other way is to have a distributed file system like Hadoop, like the Hadoop distributed file system, and you just specify where Spark has to load the data. Then this will create RDDs. Let me see if there are examples. I prefer to go directly. Yes, let's move to that. Okay, yeah, let's move to that, because this is it is almost the same thing. So, first things. I'm going to, if someone is installed Docker Toolbox, you should have something called the Docker Quick Start Terminal. Okay? Do you have? Yeah. So I'm going to launch this, but if you are using the other Docker, the native one, you just open a normal terminal. So waiting. In the meantime, well, Placido, you are following, right? With Docker Toolbox. Since he's the only one following, I'm going to show him. You have to go to VirtualBox, and just to verify that you have opened the ports. Already done? So we are going to interact via a web application. So those who are using the toolbox, if you go open VirtualBox, there is one virtual machine called default. If you click on settings and then move to network, in the advanced property there is the for matching the ports, external, internal. So these instructions are on the GitHub site. So I need to map the port 8888, yeah, with the 8888. 4040. Okay, so that's all. So those using the Docker Toolbox have this whale. Sorry for the others. So once you are there, you have to move. There are two things that you have to have in locally. Let me check. You already have this, right? So there is a folder called DXLab Smart Cities that contains all this. Inside this you have a folder called Notebook, and inside this you have to put the data, which is in another repository. In my case, I have to go copy this. Wait. Yes, that's it. So just, oops. No, this is not here. I'm lost. Yeah. Notebook. Okay, that's a zip. I unzip. So, and now I'm ready. So in principle, I go back to the terminal. I have to move to the folder that you downloaded. In my case, I put it on the desktop, but not here. I have to move there. I have to move there. LS, the DXLab Smart Cities. LS. Okay. Now, at this point, you have to execute Docker compose up. Okay. I'm going to share this instruction with you. Just let me check up. So, and in principle, Yes. Sorry? No. This is, if you are using, just I finish this part and then I switch. Because basically it's the same thing. What I want, the fact is that when you execute this instruction, the Docker compose up, you don't have, if you are not using the Docker, the toolbox, you just go to the folder and put Docker guion, I forgot always that word, minus compose up, and it's going to work. Yes, you have to download it. So what happens is that this is going to start a Jupyter Notebook server. And if you go to the localhost 8888, you will see this. You will see the data plus an output called processing GPS coordinates. Right? I'm going to put the address and the instruction inside the Google Doc so that you just copy paste it. Okay, so numbers are match more or less. So problems. Those who have problem, what is the problem? Let me go. So I have an idea. I'm going to do a demonstration. So those who are not following, you can see the principle. Those who are following, you can try it. And if you have any technical problem, we can see case by case, right? So the idea, you have all the description. The objective is to use Spark, which is a general purpose cluster computing system for processing large volumes of GPS coordinates, well, lots of files. Now we are going to work with a dataset called GeoLife GPS Trajectory Dataset, which is a dataset collected and published by Microsoft Research Asia. Most of the data were collected in Beijing. And the full data set, well, the one that they publish is about 3 gigabytes. So the collection that I put online is 30 megabytes, but once you uncompress it, is 150 megabytes. Just for making some examples. Now, the dataset, in fact, is organized. You have, for each user, you have the ID of the user. You have all the trajectories that that specific user did. That's all. The trajectory is a file containing timestamp points. The structure of the points are these. You have the latitude, the longitude. I don't know what this value is, but you have also altitude plus days, date, and time. So you have geographical information plus temporal information and others. This information is stored in the files containing the trajectories are .plt files. So in these examples, you have to, for instance, this is the collection. So I have user 10, have several trajectories, and these are all the trajectories. I cannot open it. Yes, I can open it. So, and this is an example of a file. So they are comma separated, and look, they have header. So, for those who are not familiar with Jupyter, basically this is code in Python. This is some kind of markdown language, but here you have a run button. So you have to click on the button on the run to execute the code. So for instance, I'm going to move to this part. When you start up, when you wrote Docker compose up, you started the server of Jupyter, the one who is showing this, and also a Spark cluster, a local Spark cluster. The first thing that you have to do is to connect to the cluster. And here, the way of connecting to the cluster is just importing the library pspark. So this is the input. I click run, and this is the output of clicking that. So what I have here is information about one application running in the cluster, which is called Spark Notebook. This is my application. I know that I'm connected to a local cluster, and I also know the number of cores that I am using. In this case, I'm using 2 cores, because I decided when I did the exercise, I decided just to define a cluster with 2 cores, because I don't know the number of machines. If your machine has several cores, you can ask for more. But well, the interesting part is that if you click here, you will see the Spark user interface that shows you information about the jobs in the cluster. I'm going to skip this because for that time being there are no jobs. So let's move. So the first thing to do is we have the log files. We need a way to load them into Spark. I mean, to put it into the cluster. In Spark, this is done using. Also remember, SC means Spark context. This is the access point to the cluster. So in order to load data into Spark, you use an operation called text file, where you specify the path to the file. So here you have 3 examples of how to load one specific file, how to load all the logs of a specific user, all the trajectories that a specific user did, and all the logs of all the users. So I execute this cell. I'm going to re-execute it, and you're going to see why. This is the output. Every time in the notebook, when you put the last variable, which is not assigned, will be printed into the notebook. But because of this configuration, you see all the variables. Well, all the variables which were not assigned, all the declaration expressions that return a value that was not assigned to a variable. So the idea is that loading a file, a set of files or multiple files, result in variables of type resilient distributed datasets, which means that the data is already in the cluster. And you may say, yeah, that's nice. So we have variables, but the fact is that, remember, the distributed datasets live in the cluster. So these variables, they do not contain, they are merely pointers. And the proof is that in this example, I execute this line. This line, what it does is, for each variable RDD, I'm going to compute the size in bytes. And look, for RDD1 we have 56 bytes, for RDD2 also 56, for RDD3, although RDD3 is supposed to load 150 megabytes. So the idea is that to make you conscious of the fact that the data resides inside the cluster, so all the computations has to be executed in the cluster. When you use Spark, all the operations are over RDDs. These operations are executed inside the cluster, but at some point you have to collect the data back from the cluster to your machine, to your local machine. In Spark, there is an operation for that called collect. So if you get if you have an RDD and you collect it, for instance, this is running. So this is the first result. This is the second result. So the third one is going to take more time because the file is bigger. Well, all the data set is bigger. So what I'm going here is RDD1, I want to collect you. The result is a list. So for this variable, I print the type, which is list, the size of the list. Now, we are using bytes. This is 60. This is more than a megabyte, and then the number of elements. So, if you remember, I told you that the GeoLife dataset is 3 gigabytes in size, and this is not big data. This is just a toy example. So, what happens if you load everything and you collect them? You are going to use computational resources. You are going to use the bandwidth plus all the resources in your machine. So, rather for just collecting a sample or a subset of the information, Spark offers you some operations. Like, for instance, you have first and you have take. With take, you can collect the n first elements in the collection, well, in the RDD, or just the first one. So, for instance, in this example, what I'm doing is I'm collecting the full data set, 150 megabytes, and the result is stored in RDD3, the pointer. Then we ask for the first element and the first 3 elements, and this we print it. And this is a fast operation because we are just getting from the cluster the elements that we want. Okay. Okay. Well, I mean, that's the problem with Linux. You said Ubuntu, right? Yeah. I mean, the instructions. I asked yesterday one of the students working with Ubuntu that told me that he followed the instructions on the site. No, Docker, no. To compose separately, a different package. Well. So I continue, and then, as I said, we go case by case. So just to understand the principle of what we are doing. So now you are supposed to. You have seen how to load data. You have also seen that the files contain some metadata, right? So this part, I'm loading the file, the content of a specific file. I'm storing it into a distributed data set. I'm taking and printing the first 10 lines, and we have metadata and coordinates. So the logical thing to do is to filter the lines who are not coordinates. In Spark, this is done using the filter operation, which is there. Yeah. The filter operation, this is functional. Expects to receive a function, and this function will be applied for every element in the RDD. Remember, behind the scenes there is the map reduce paradigm. So this function is going to be applied for every element in the collection, and the result is going to be a value true or false. And the semantics in the Spark is that Spark is going to keep all tuples who answer true to the function. So in this case, I have a function called not trace metadata. What happens is that for RDD1, which is one log file, I'm going to filter using that function, and that function is going to split the line, because I already know that lines which are coordinates are contain 7 groups. This is a classical way of parsing. So this is an example. The result of applying this operation is a new RDD. I print the first 3 elements of this RDD, and now we don't have metadata. So I continue like this, and then remember that there is a lot of information. We have latitude, longitude, altitude plus others, but what I really want is to have latitude, longitude plus timestamp. So we have to transform from one string to a new data structure. So in this example, the principle is the same. We have to use an operation called the operation map, and we pass a function that will receive each line in a log file, and will transform that file to a new structure, a dictionary like this one, a dictionary containing latitude, longitude, and timestamp, and the result is a new RDD. Now, before we had strings, now we have dictionaries. or hash tables if you prefer. And now with that, you can play with this. So for instance, you have information about people moving in a city. So I asked you to obtain a Google Maps access token, right? So you have your access token. You can, if you don't have your access token, you can still execute the example. So this part is just for configuring a library which uses Google Maps. And using Google Maps, I'm going to skip to this. Yeah. And using this library, basically what we are going to use is to create a heat map. For creating a heat map, we have to prepare the data to adapt it to a specific format. This format has to be tuples of the form latitude, longitude, like this. And with this, we can create a heat map. So here you can see that one person moved from a different city to Beijing, and you can see where the people moved around, right? Also, you have information about the trajectory. You can detect the origin and the destination. So using the same principle, you use a cluster for filtering and treating the data. You collect the data and you just focus on the information that you want to show. In this example, I'm doing the same. I'm showing how to compute, to find the origin of a trajectory. Basically, you have several points ordered by timestamp. If you want to obtain the origin, you have to collect the first point. And this is the first point of that specific trajectory. Now, for finishing, the idea is that you have here some exercises. You have to play, you have to try to find the origin and destination and plot it into the map. You have also tried to plot a heat map with all the information, with different information of different users, and see what happened in the cluster every time that you execute an operation. For instance, here you can see that these are the operations that were computed in the cluster. You can see the data processing graph, which is a workflow, data flow. So please try to do it, execute the code, visit the web user interface, and let's see what you discover. You have to try to check the limits. What happens if you load the full data set and you send it over the network to Google? What is going to happen? So you have to try different quantities of data values, and the idea is that you try to discover things. So for instance, what does this mean? The fact that there are some red points means that there are more points at these specific points. Why there are more points here than here? That's a question. Why there are more points here than there? That person uses a train for moving. If you have taken the train, you don't start at full speed at the beginning. You start slowly, and then you move fast, and then once you arrive to the city, it goes slowly. So the idea is to explore the data collection and try to find interesting stuff. Now you have seen what you can do. I'm going to start visiting you for the technical problems.
Anyone has questions? Ah, it's not moving, okay. If you have some technical problems, please ask Javier, so he will help you. I suggest to everyone to, during the night today, try to follow all the instructions in the website. We sent a message for all the participants with 2 links for the tutorial today and for the tutorial tomorrow, so you can follow and you can arrive in this part, so you can restart tomorrow afternoon and be ready to tomorrow morning. It's really important you to pre-install every software for following the tutorial, okay? There. Don't forget that tomorrow we start at 8:30. Okay? 8:30. rápido, vai que o dono chega, né? Pessoal, o evento está sendo transmitido ao vivo no canal da EAD no YouTube. Está sendo transmitido ao vivo e vai ficar gravado lá no canal do YouTube, tá certo? Tem o Instagram do evento, FRBR School, postando foto lá, se você quiser postar alguma foto, FRBR School também, 2017. FRBR School 2017, hashtag FRBR School 2017. Se você postar alguma foto, marca aí e usa a hashtag.